I'm Kainson, the Tech Pro, and today we are going to answer this question: what is regularization in machine learning? I want you to keep in mind this relationship between bias, variance, underfitting, and overfitting. We are saying that if there is too much bias, then we have underfitting. If there is too much variance, then we have overfitting. So there is going to be some kind of trade-off between the two. So regularization is a technique that is used to control overfitting. So we use regularization as a technique to prevent overfitting or to reduce the variance. Because if the variance is much, we have overfitting. So regularization kind of controls the variance, preventing the model from becoming having too much variance. So the key word is that we are trying to control variance. Let me take out this. So the key word is we are trying to control variance. That is what regularization is for. Now I'm not really going to make it. I'm really going to make it a bit easy. So now it involves adding some penalty term to the model so that the model coefficient is not too large. So one of such penalty term is the sum of squared of all the coefficients w. So let's start with something we know, and then we go from what we know to what we don't know. Already you know that we can model a relationship by fitting a polynomial regression line or even a linear regression line through a data set. So in that case, we are talking about polynomial curve fitting. And polynomial curve fitting is interesting because once you have the order of this polynomial to be order of 1, you still come down to a linear model. So I'm going to write the polynomial curve fitting equation, and then we see how we can use it to arrive at how we can actually improve this model to avoid overfitting. So for m order polynomial, let's say we have a polynomial of order m. We have a model to be y of x and w equals w0 plus w1x plus w2 x squared plus wm x to the power of m. So this is a polynomial of m order, and it can be used to represent a regression model. Right, so we can actually write it in this way. Sigma of from j is equal to 0 to m wj x to the power of j. So what you can see that we have y to be a function of the x and w. Now you can see that this is a linear function of w because you can see that w is linear, meaning that at this point w is now a vector in m-dimensional space. All right. So it means that we will have an error function that will be based on w. So okay, let me write in a different color. So we'll have an error function e. Now I'm going to write it the way it is in my website. So, and after I'm going to explain it. So we have error function to be e, a linear function of w is equal to 1 over 2 summation of I or j, anyone you want to use, equal to 1 to n, a function of xi and w. Of course, the error have to be a function of x and w minus the actual training response variable corresponding to xi. We're taking the square. So now when you have something like this and want to perform regularization, we are going to add some time to this error function. So let's say the term we are going to add, of course, in regularization, we are not actually interested in what we are going to add. I'm just trying to make sure you understand the concept of regularization. But for details sake, for me to add some details, what term you can add gives you an adjusted error function, and the term we are going to add is called a regularization term, and is given this way: lambda over 2 w squared. So this is what makes this this is what the regularization term or the penalty term, adding it gives this adjusted error function. And this adjusted error function, as it applies to this model you have here, prevents or limits overfitting in the model, right? So the question is, what is this term, lambda, and what is w? Of course, you know w already, but lambda prevents the penalty term from being too small or being too big compared to the error term. So basically, what I want you to take home from this lesson is that regularization controls or limits overfitting, overfitting. So that is what regularization is for, and it involves adding a penalty term to the error function, or to be able to limit overfitting, adding penalty term to the sum of squared error of the coefficient w to limit overfitting. Now, it may not sound very interesting to you, the explanation, but with time, if you follow my lessons, gradually this concept will become very clear to you. So now I'm going to show you the next question, question 22, differentiate between regularization and generalization. So I'm going to stop here. I'm going to thank you for viewing. Remember to subscribe and also share this video around. Also, if it's been informative for you, do like it and let me know how you feel.